So we're still in 3.2, measures of spread, and we're talking about the empirical rule. The empirical rule is used to approximate information on bell-shaped histograms or data. So you have this approximately symmetrical data that comes out like this. You can use the empirical rule, and what it says is, here's your mean. If you add and subtract one standard deviation, it says 68% of the information is between one standard deviation above and below the mean. It also says 95% of the data is within two standard deviations above and below average, so 95%. 3 standard deviations is almost all, or sometimes it's 99.7%. Also depending on what text that you're using. They're both correct. So almost everything is 3 standard deviations above or below. So the type of questions you'd be asked is to apply the empirical rule on bell-shaped distributions. So assume the heights of women have a bell-shaped distribution, which means I can use the empirical rule. The mean is 63.6, so that's the middle, that's the mean right there, inches. And the standard deviation is 2.5. So what we're going to do is I'm going to add a standard deviation, add 2, add 3, and then I'm going to subtract 61.1. Subtract it again, 58.6. And subtract 3 standard deviations, 56.1. So what percent of the data is between 58.6 and 66.1? So they want to know what percent is this. Well, you notice it's the 68 plus this right here. So if I take 95 and I subtract out this 68, so 95% minus the 68, I'm going to be left with 27%. But that's split between here and here. So if I divide that by 2, I know that 13.5 is in this light blue area. So if I want the percentage from here to here, I'm going to take 13.5 plus 68 equals 81.5%. Alright, let's do it again. We're going to use the empirical rule to find percentage scores. The mean competency test is, the mean score is a 65. I have a bell-shaped distribution. 65. 1, 2, 3 above, 1, 2, 3 below. The standard deviation is 4, so I'm going to add 4 once, twice, here, and now I'm going to go below 65, so below standard deviations, 61, take it away again, take it away again. So they want to know what information is between, what percent of the data lies between here. Well, the empirical rule, this is 1 standard deviation above and below. The empirical rule says 68%. You can only work with the numbers that the empirical rule gives you. Next, Chebyshev's inequality. This can be used for any data set. It doesn't have to be approximately normal or have a bell-shaped. It can be any data set. This says within 2 standard deviations, 75% of the information lies. And within 3 standard deviations, 89% or 88.9 depending also on your book. That's rounded to one whole. This is, your computer might ask you to go out one decimal place. So, as a part of a public health study, systolic blood pressure was measured for a large group of people. The mean was 120 and a standard deviation of 10. What information does Chebyshev's inequality provide about this data? Well, it says within 2 standard deviations, 75% of the data lies. So I take my 120 and I'm going to add and subtract 2 standard deviations. So the standard deviation is 10. So 120 minus 20 is going to be 100. If I add 20, it's 140. So it says 75% of the data lies between a blood pressure of 100 and 140. Or we could say within 3 standard deviations, we're going to have 88.9% of the data. So I take my mean of 120 and I'm going to both add and subtract 3 standard deviations. So that's 30. So 120 minus 30 is 90, and 120 plus 30 is 150. So Chebyshev's inequality says 88.9% of the data lies between blood pressures of 90 to 150. Only can work with these numbers when using this inequality. So last in 3.2 is coefficient of variation, CV. It's used to compare spreads of data sets whose values have different units. So you're comparing spreads of data sets with different units. It's found by taking the standard deviation divided by the mean. So here I'm going to compare precipitation in Georgia. So the CV is the standard deviation divided by the mean. Round to 3 decimal places. I'm going to compare and then I'm going to compare that to temperature. So standard deviation divided by the mean. So we can compare spreads of different data sets with different units. This has a larger spread, 15% compared to 2%. The CV is larger spread.